All right, here we go. I'm going to do this now that my house is slowly not under construction for the time being. So I already did number one. I think I did number one with a bunch of you guys. So here's what it looks like if you wanted to see it, where x equals 1. I go back and I check to make sure that x was 1. All right, number two. So we see that the first part of the problem has a base of 3, and the second part of the problem has a base of 27. So what we have to do is change either the 3 to a 27 or the 27 to a 3. So the easiest thing to do is always to reduce in math. So we're going to keep um, our 3 and change the 27 to 3. So we have 3 to the power of x minus 7. Well, 3 to the third power makes 27. Now that I have the same base, I have x minus 7 equals, and I can distribute, 3 times 2 is 6x, right? So subtract x, I get negative 7 equals 5x, divide by 5, divide by 5, I get x equals negative 7 over 5, and I know my answer is correct because the answer key at the bottom says so. So let's look at number 3. Number 3, we get an 8 and a 16. In math, we reduce, so our common factor there is 2. 2 to the third power for 8, 2 to the fourth power for 16. Multiply those things all together. By the time I get my x alone, I end up with x equals 16 over 3. So you can pause that there if you need to see the work. Number 4, e to the negative x equals 6. All right, anytime there is a variable in our exponent, we are automatically signaled that we must do a logarithmic function of some kind. So on number 4, we see e, and e means basically the inverse of a natural log. Okay, if I see e, I know natural log automatically. So now what I have to do is take the natural log of both sides in order to solve for that variable of x. Well, now I have something called the power rule, and the power rule tells me that when I set up my logarithm, if I have an exponent within the parentheses, I need to rewrite that equation into a new equation, to a new formula. So now the power rule tells me that my exponent is now multiplied by my base, by the natural logarithm of my base. Well, the natural log of e is 1. So now I have negative x equals the natural log of 6. I'm going to divide that by negative 1 because I need to get that off. Let me go to GeoGebra and look that up because I don't have my calculator of 6. We're going to go divided by negative 1. So the answer is negative 1.79. So x equals negative 1.79. That's what you should have. Remember, if I had, this is just a side note, nothing to do with this problem. If I had the log of 10, that equals 1. 10, a base of 10, to be the 10th power, that would be what power makes 10? 1. So when I have the natural log of e, e to what makes e? Well, 1. All right, that's a side note, like I said. All right, let's go to 5. 5, I have 0.25 to the power of x equals, or excuse me, minus 0.5 equals 2. I'm going to add 0.5. So now I have 0.25 to the power of x equals 2.5. Well, I have a variable in my exponent. I don't have an e, so I'm going to take the log of both sides. Oopsie, let's see, the log of 2.5. And sorry, my handwriting looks kind of crazy. I'm doing this by hand on my computer screen. All right, here we go again. We see that we have a exponent within our logarithmic function. So we move that to the outside and multiply that by the log, 2.5. Well, now I just divide it by the log of 0.25 because that's x times that logarithm of 0.25. We could substitute that if we wanted and make say like y, x times y. We don't know what that is. We do, but the calculator could tell us. So we're going to divide that off and we're going to go to GeoGebra and we're going to type in the log of 2.5 divided by the log 0.25, I think it was. Yep, let me make sure oh geez. Okay, hold on. The log 2.5 divided by the log of 0.25. There we go. Negative 0.66. Negative 0.661 or negative 0.66 is what x equals here. X equals negative point or 0.6. Oh my goodness. 661 for number 5. Number 6. Subtract that 3. We have to get our x. Remember, we got to quote unquote undress the x. So now I'm at this, okay? Another variable in my logarithm, okay? But let me think about this for a second because I wrote some notes down on my paper. I think I'm right. So we're going to go the log of 7 to the 2x power equals the log of 5. Well, we're going to rewrite that. 2x log of 7 equals the log of 5 due to our power rule. Okay? This is saying 2 times x times the log of 7. So I'm going to divide this by 2 times the log of 7. So I now have the log of 5 divided by 2 times the log of 7. So let's go here. So we have the log of 5, the log of 7. We're going to go 2 times that. Oh, it's going to get real angry at me. It's kind of, I like Desmos better when it comes to this. So I'm going to go 2 times 0.84509. I get that. That's on the bottom. So now I have 0.69897. Try not to forget a calculator when you are doing this. And of course, it's real mad at me. Let's delete that one so I can see it. 0.69897 divided by 1.69018. I should get 0.41, and I do. So when I do my log formula, I do this first, then multiply it by 2, then divide this by this, and I get 0.41. X equals 0.41. All right, number 7, subtract 6. What is that? 94 equals 94. So now I have the log of 10 to the power of negative 12x equals the log of 94. So now I have negative 12x times the log of 10 equals the log of 94. Okay, so I'm going to divide everything. Divided by negative 12 times the log of 10. So let's go over here, clear everything. Delete. Hold on. Alexa, stop my timer. I was doing math, or I was cooking potatoes while doing math. All right, it'll be okay. So we have the log of 94, divided by, we're going to do parentheses. Oh, divided by parentheses, negative 12 to the log of 10. Nope, just the base of 10. It really gets mad. I might switch to Desmos. Let's see. Negative 0.16. Yep. I don't know why the answer key says negative 0.165 because I did this earlier too, and I got the same answer, this negative 0.1644. So we'll just write the work, do the work, and then write negative 0.165 because that's what the answer key says. So the log of 94 equals negative, or x equals negative 0.165, even though the calculator several times has said 0.164. Anyway, all right, so there's that work. I kind of drifted off there. The sweet potatoes distracted me. All right, plus 16. Plus 16 over here. We have zero point 0.2 times 3 to the power of x equals, what's that? 51. 51, yep. All right, now I'm going to divide it by 0.2. 3 to the power of x equals 255. Okay, log of 3x equals log of 255. There's a 5 there. Okay, now I have to erase this because my handwriting is atrocious right now. Equals the log of 255. Bring that back in. So now I have x times the log of 3 equals the log of 255. Divide this by the log of 3. So now I have the log of 255 divided by 0.477. What in the heavens did this do? Delete. Okay, let's try it again. Okay, 5.78 divided by 0.477. Why is this doing that? 12.11. Plus 16 plus 16. All right, so we were looking at this. The log of 255 divided by the log of 3. Still trying to figure out. I freaking see my own error now. The log. Still trying to figure out. I freaking see my own error now. The log of 255. The log of 3. And so now I have 2.406 divided by 0.477. And that equals 5.44, 5.04. Yep. It was my own misinterpretation of how to type this into the calculator and actually paying attention. Okay, so now that we figured out that GeoGebra hates me, we're going to switch to Desmos because over it. All right, let's check this out. So number 9 says check for extraneous solutions. Well, we have the same base here. So just like in number 3 and number 1, we had to get to the same base so that our exponents could equal each other. Well, now we have the same base, so our our arguments can equal each. So we have 4x plus 1 equals 2x plus 5. Okay. Subtract 1 from both sides, subtract 2x from both sides. I get 2x equals 4, x equals 2. So what it wants me to do is say, does 4 times 2 plus 1 equal 2 times 2 plus 5? Well, 4 times 2 plus 1, 9. 2 times 2 plus 5 equals 9. Yay, they're right. All right, let's look at this. So remember, anytime that x is within that answer, this is called the answer, base, argument, answer. We just say 2 to negative 1. If x is there, whatever is here becomes the exponent of our base. So 2 to negative 1. Anytime we have a negative in a negative 1 in our exponent means 1 over. 1 over. So 2 to negative 1 equals 1 half. All right, let's look at it right here again, because that might have been a little too quick. Divide by 4. I have log to the base of 3x equals 7. I now have my base, my argument, my answer. 3 to the power of 7, 3 to my argument, equals x. Base, exponent, answer. Base, answer, exponent. Base, exponent, answer. Base, answer, exponent. Always remember that. If there's an x there, you've done the hard work. The hard work's already done for you. So 3 to the power of 7 equals 2187. Number 12. Okay, subtract by 1. So we have negative 2 to the natural log of x equals negative 5 now. Divide by negative 2. The natural log of x equals 2.5. Well, this is the natural log of the base e of x equals 2.5. So base, answer, exponent. Base, exponent, answer. Well, e to 2.5 equals 12.18. So this right here is the same as that, which means 10 goes right there, base of 10. Okay? Anytime it just says natural log of a number, there is a hidden e. The natural log to the base of e, the answer will be x. What exponent do we need? X is in the answer spot, so we just flip our equation. E to the power of 2.5 equals what? It equals 12.18. All right, this one's your little bonus question. I love it. So I'm going to say a couple rules here of logarithms. Anytime we have the natural log of blank, or a, we'll say the natural log of a in this instance being x, plus the natural log of b, and in this instance b equals x minus 2, that equals the natural log of a times b. So natural log plus a natural log equals that natural log in parentheses, that first thing times the second thing. Now, new rule. Anytime we have the ln of a equaling b, we now have a equals e to the power of b. Sorry, let me make that clear. Okay, natural log. So what this leaves me with is x times x minus 2 equals 1, which 1 is now e. Do my distributing, x times x is x squared minus 2x equals e. Well, automatically, boom, right there, I have a quadratic function that I can solve for x. So I subtract e, subtract e. So now my new equation is x squared minus 2x minus e equals 0. That's going to be set up like um, 2, let me go back, 2 plus or minus the square root of 2 squared plus 4 times 1, not plus 4, I know this equation, minus 4 times negative e over 2 times 1. So now I have 2 plus or minus the square root of 4 minus 4, negative 4 times negative e is going to be plus 4e over 2. Okay, ready for it? Um, I can factor this out. So I'm going to go and do that right now. And I'm going to end up with, no, I'm not. I'm going to divide everything by 2. I'm going to do the square root, square root. Okay, so now I have 2 plus or minus 2, because I did the square root of this, right? Let me read my notes. Yep, to the square root. I'm going to factor out. I went too fast in my notes, and I'm just so unfortunate for that. Let me go back. I'm going to factor out, like I said, 4 times 1 plus e. There we go. 2 plus or minus the square root over 2. Do that, square root. So now I have 2 plus or minus 2 times the square root of 1 plus e over 2. Well, I can divide this by 2, divide that by 2. So now what I end up is 1 plus or minus the square root of 1 plus e. Sorry that my brain kind of stopped there for a second. I want you guys to see that whole thing. So I was right when I said right here, and I confused myself. We are going to factor right there, factor that 4 out so we can do the hard work. All right, over here. I'm going to go ahead and erase that so we have room. Here we have two bases that equal each other. All right, so we end up with 11 minus 6x equals 1 minus x. Add x, subtract 11, subtract 11. So now I have negative 5x equals negative 10, divide by negative 5, divide by negative 5. I have that x equals 2. I can't stop there. So now what I know, my number one fact that I know about logarithms and natural log is that x must be greater than 0. So when I go 11 minus 6 times 2, well, that's 12. 11 minus, that's negative 1. So automatically not true. But I'm going to check it just because 1 minus 2 on the other side equals negative 1. Yeah, they equal each other, but there is no solution. Do not get caught up on the fact that they do equal each other when you do it by hand, because there is no solution if x is less than 0. X must be greater than 0. It must be a positive number. So the answer to 14 is no solution. All right, number 15. Subtract 15. Subtract 15. So I get 2 log of 2x equals 16. Divide by 2. Divide by 2. Log to the base of 2x equals 8. Remember, I now have my base, my answer, and my exponent. So I have 2 to the power of 8 equals x. That's an 8, I promise. And so 2 to the power 8, x equals 256. My base, my exponent, my answer. If it said log base of 2 to x equals x, then we got to do some finagling in our calculator, some change of base. We don't have to do that. Just 2 to the power 8, 256. Number 16, we're going to divide everything by 6.5. I now have the log of the base of 5 to 3x equals what I get, 3.077. Now, I have my base, my exponent, and my answer. So I have 5 to the power of 3.077 equals 3x. 5 to the power of 3.077 equals 141.492 equals 3x. Divide by 3, x equals 47.16. There you go. That is your homework assignment.